Okay, in example 8, we're going to solve an exponential function in quadratic form. Before we do, sometimes we can get solutions that are extraneous solutions. Sometimes the methods used to solve an equation introduce an extraneous solution, which is a solution that is correct algebraically, but does not satisfy the conditions of the original equation. One such situation arises in solving when the logarithm is taken on both sides of the equation. In such cases, remember that the argument of the logarithm must be positive. If the number we are evaluating in a logarithm function is negative, there is no output. So let's take a look at this example here. We want to be able to solve e to the 2x minus e to the x, which is equal to 56. So the first thing we want to do is get one side of the equation equal to 0. So in step 1, we rewrote the equation. And so in order to get everything on one side, in step 2, we subtract 56 both sides of the equation and set this equal to 0. And then step 3, we want to be able to factor by the FOIL method or the AC method or the CA method. So over here we have a quadratic form. We have e to the 2x, that's the quadratic term, minus e to the x, which is the x term, and then we have the constant. Well, keep in mind that this is negative 56. The middle term is negative 1. So what two numbers can you multiply to get negative 56 and add to get negative 1? What's 7 and negative 8? And then what two values would we have to multiply to get e to the 2x? Well, it's e to the x times e to the x. So we have e to the x plus 7 times e to the x minus 8, which is equal to 0. And so in step 4, now we can use the zero product rule and then set the factors equal to 0. So we have e to the x plus 7, which is equal to 0. And then we have or e to the x minus 8 is equal to 0. And so now when we isolate the exponentials, or isolate the term with the x variable, we get in step 5 e to the x, which is equal to negative 7, or e to the x, which is equal to 8. So if you take a look at these solutions, one of them is negative. And going back to what we just said at the very beginning, okay, in step 5, because it's negative, this is an extraneous solution. Okay, and again, what does that mean? Well, that means that, again, we got a solution that is correct algebraically, but because it's negative, it would not satisfy the conditions of the original equation. So therefore, we're going to reject the equation in which the power equals a negative number, and so we can accept the one that's a positive number. So in step 6, we're going to accept e to the x, which is equal to 8. And then we're going to solve the equation in which power equals a positive number. So we're going to take the natural log of both sides. And so then we're taking natural log of both sides here, e to the x. We can then solve for x because now we have x, which is equal to the natural log of 8. Now, when we plan to use factoring to solve a problem, we always get 0 on one side of the equation because 0 has the unique property that when a product is 0, one or both of the factors must be 0. We reject the equation e to the x and negative 7 because a positive number never equals a negative number. So the solution, the natural log of negative 7, is not a real number. And in the real number system, this solution is rejected as an extraneous solution. Let's take a look at what that looks like on the calculator. If we put in the natural log of negative 7, again, you will see that it's an error, non-real number. So therefore, that provides the information for that part. Now, does every logarithmic equation have a solution? Well, no. Keep in mind that we can only apply the logarithm to a positive number. So you always check for extraneous solutions.